Thanks, everybody. We have 34 people in the audience. I'm very, very pleased and happy to see you all here. It is my pleasure to introduce Jonathan Ebel from Verivend. And he is a seasoned software architect and proven technology leader. He has played an integral role in bootstrapping, leading, and scaling software engineering teams and products for several hugely successful software companies. Most recently, John was chief architect of ACV Auctions. There, he led and grew the software engineering team and created ACV's product team, which was responsible for the company's overall product priorities and roadmap. John also managed the re-architecting of ACV's platform as a microservice architecture to support multiple focused engineering teams and a greater level of product expertise. So prior to ACV, John served as a global engineering manager at Liaison. He led the re-architecting of the company's domestic product for a new global market, meeting the needs of customers on every continent. John has expertise in both the initial creation of software products and processes, as well as long-term maintainability, extendability, and scalability of those products and processes. He has an MBA in international management from Canisius, and his undergraduate degree in computer science and engineering from the University of Buffalo. And if I remember correctly, John, you also have a background in music, right?
Yes, I do.
Which is very important to me.
Yeah, it's my first love right there, yeah.
So thanks for being here. Please go ahead.
Well, thank you all very much for giving me the opportunity and inviting me to come give this talk today. It's a real bummer we can't do it in person at Buff State, but this is going to be just fine, I think. So my talk today is going to be on performance through eventually consistent models. And if any of you know anything about me, you know this has been my passion at pretty much any company that I've worked at. I even have done this in the this sort of thing that we're going to talk through as a consultant for other companies as well. Pretty much any company that maybe anyone has worked at, you've encountered enormous, large, what we call ball of mud systems, and maybe been through the pain of breaking them up into smaller pieces and what comes with it. And that's kind of what I wanted to talk through today. I want to talk through taking something big, making it small, and then dealing with the ramifications that come with that fractionalization of data, if you will. So what are we going to look at today? I'm going to talk about how most systems begin. And then I'm going to make a case for the isolation and protection of models. Everyone can see my screen, right?
Yes.
Thumbs up. Okay, excellent, great. We're going to see some of the ways that you do it wrong, because God knows I've seen some of the ways to do it wrong. I've even done it wrong myself in the past for sure. Once you've gotten to the point where you have actually successfully distributed your system, you're going to run into new problems. And that's where we're going to be talking about data, what to do with data, because it will get fractionalized. Then we're going to look at a solution, which is event streaming and eventual consistency. And then we'll do a wrap up. So first things first, I wanted to show a big, ugly system. And so I just did a Google image search for large, I think I looked for like really large database schema. And this is what came up. And I had to laugh. Anyone who's probably worked at any industry in any enterprise or any company would say, like, that's not that big, right? That's not a big database schema. What I've seen coming into some companies where you have established products, or even starting a company, a small startup that ended up growing into something big, is that initially every system started with one solution. There was one problem, and you started to write a program or an application to solve that problem. And if you're lucky, people like it, and they start asking, can it do this too? Can we have it do this too? Can we have it remind us when we have to call our customers? Can we have it, I don't know, can we have it also start making shipping calculations for us? And you go, yeah, of course. And you start doing this, and you start changing the initial intent of your application so that it covers a lot more ground and does a lot more things. But what tends to happen is as you grow, if you're lucky, again, this is what happens. It's a weird sort of paradigm. If you're lucky, you run into these problems because your application has gained traction. What you see though, is you start to see tight coupling throughout your entire system. And as you try to hire more people, more engineers, whatever, you'll see that they're not able to deliver as quickly anymore. Your logic starts to get all scattered. It's not consolidated anymore, because now you're solving all sorts of things. There's logic in your database now. There's logic up in the presentation layer. It's everywhere. It's just very difficult to innovate now because things are so tightly coupled and so messy. We call it like a ball of mud. It turns into like a big ball of mud. It's very hard to scale for a growing team. And your engineers and everyone working in the system, they can't really become experts in anything anymore. They have to become a jack of all trades because your system does so many things. There are so many models all over the place now that are intertwined, that how can you possibly become an expertise, and how can you possibly expect to innovate? And of course, the business demands are still there. We got to get it out. We got to get it out. And so they're like, don't worry about writing crummy code. And the engineers are like, oh, that's all we worry about. It's got to be great. Don't worry, we'll manage it with hardware scaling, right? We'll vertically scale it. If the code is crummy and doesn't run well, we'll horizontally scale it with nodes and Kubernetes or something. But what you'll see is that doesn't always work. On the left-hand side, I have our standard monolith 3-tiered architecture, whatever. That application logic thing, that's what we're really focusing on. That's where the models are. The bottom right is Amdahl's law, which is a great tool to use to show diminishing returns on hardware scaling, but it does have some limitations. I prefer this little tiny formula up top. And with this little formula, alpha represents the fraction of computing that has to be done in a serial manner or sequentially. So 1 minus alpha is the fraction of computation that can happen parallel, concurrently. And P represents the processing force that you can apply. So let's say P is 4 cores or 4 nodes or something like that. So let's say 30% of your application must be run sequentially, 70% can be run in a parallel fashion concurrently, and you throw 4 cores. Okay, now you throw 8 cores. Now you throw 16 cores. This function will yield diminishing returns. So you're better off probably optimizing your system and optimizing your code and performance tuning. Okay, let's look at something else kind of interesting. So this is a map. If we were all together at Bus State, I'd be asking questions. Does anyone know what kind of map this is? But I'm not going to do that right now. This is a map, and we can all agree that a map is a model. A map solves a problem. That's why we have them. If there wasn't a problem, we wouldn't need maps. This particular map is called the Mercator map. It's a super famous map. We still use it today, but it's very old. It came about, the Europeans created it around the time of the Renaissance. And it was created for their explorers and merchants so that they can navigate nautical routes. They can navigate sea routes. And the reason this map worked really, really well is because it perfectly preserves cardinal coordinates in the oceans, in the seas, and the waterways. So if I was navigating the coast of Greenland, I can use a compass and this map and always know where I am. It worked beautifully. Again, I think we still use this map. Portugal, New Orleans, whatever the case may be, you can always use this. But if someone said, use this model and tell me how much bigger is Africa than Greenland, you'd look at this model and say, they're roughly the same size. Of course, most of us know that's absolutely not the case. Not even close. Africa's at least 11 times bigger, right? This is not the model for that question, right? Now you could start manipulating this model and start changing it now to solve also landmass sizes. You could say, I don't know how you would do it, but you could start saying at certain latitudes, on land, the scale of miles starts to change. It would be convoluted. It wouldn't solve that problem very well. And it would complicate and convolute the initial intention of this model. But if you needed to actually compare at a glance landmass sizes, you would probably use a different model. But again, it's not good at nautical direction. That's not what it was made for. Okay, so what I'm trying to get at here is when you have big systems that are full of all these models and patches and things over here and intertwining solutions and code, you are not going to get a good result. And so my case is start isolating those things. Start identifying your business capabilities and start breaking them out. I even say break them out geographically. Put it in a different code repo, right? Give it its own database persistence. We're going to talk about that in a minute. When you isolate these things, all of a sudden innovation becomes possible again. You can start focusing on data consistency, the quality of the data. You can focus on your testability, your extendability, your performance, your scalability of that particular thing, and not worry about everyone else's models and their solutions. Even more so, you can take that business logic, which felt consolidated, or I'm sorry, not consolidated, the opposite, felt scattered previously, and now you can consolidate it in your invariants. These are the rules, the business logic. What better place than to put it directly in the model? That is very hard to do unless you break it apart and you put a boundary around it. Say, this is my model. Even more, you could start identifying what are called aggregate roots inside your model and say, these are the external references into my model. And this aggregate has other things associated to it, which all have to be persisted at the exact same time because transactional consistency is the only thing that's going to keep my data clean. For just a crude example, but I'll go with it anyway. Let's say we had an ordering system and we had an order entity, And the order entity had to have order items. Otherwise, it's not valid. You can't have an order without order items, let's say. Well, if you had the persistence of that order and the persistence of the order items in separate database transactions, what can happen? It is possible to have your model be in an invalid state. That's the worst case, right? We want good, clean data. This gives you the ability to make things really clean, really performant, et cetera, et cetera. One other thing to keep in mind, this is like a sure sign that your systems are getting really convoluted, is when you start to see a blending of context. What I mean by that, and this is something that I've seen in the past too, many, many times, is as your startup starts to grow, right? I saw this with our startups. We were just a group of people in like a corner of a room, and then all of a sudden we had departments across like a campus, across buildings. It was what an honor to be part of something like that. But it came with problems. Some of the problems were the meaning of words started to change because a division of the company, a word like customer meant something different. A word like order meant something different. And our code was still using the same terminology. It didn't make much sense, and it didn't reflect the changes that were happening in the business. So what I say is every single model must exist inside a context. So you can identify those contexts and say, when we say customer here, it means trucking transporter. When we say customer here, it means dealership, right? You can isolate these things, and that's where your models go. They have to live inside a bounded context. This even happens with English. In fact, it just happened the other day, and I popped this in here. At my company, we closed the deal, right? We got a signature on something, and we were like, sweet, that transaction's done. And I was thinking about it. I'm like, earlier that day, I had used the term transaction. And even now, while we're talking, I've used the term transaction numerous times, but I've used it in like a data science, data architecture mentality, right? I'm thinking ACID, atomic, consistent, isolated, durable. That's when we're talking about databases, what we mean when we say transaction. But a business, it's just a business deal. So it happens everywhere. Isolate your models so that words have specific meaning in them. This one's kind of stupid, but I walked into a room full of bats. Well, what's the context? Was it an abandoned house or was it a sports store, right? That's stupid. But anyway, hopefully I've convinced you guys that it does make sense to isolate these things, to break apart these models, right? So let's assume that you're all on the same page with me and you agree, yeah, this is a good idea, right? What do? Well, it's obvious. It's microservices, right? We just roll out microservices and everyone's happy. Everyone's doing it. All right, let's do it. So let's say this is our system right now. We got our big database. We got our big monolithic ball of mud that's beating the hell out of the database and some presentation layer or numerous presentation layers. I'm going to kind of not talk about the presentation layers too much. There can be a number of those. We're really going to focus on the models. Okay, we've identified 5 different bounded contexts, 5 different domains, capabilities of our system that we can isolate and start really excelling at and innovating on. Cool. Well, now instead of one crappy system beating up our database, we have 5, right? This isn't necessarily progress. Maybe it is a little bit because now the customer service team can start innovating on what they're doing and performance tweaking it and scaling it. And the customer recommendations team can do the same. But if the inventory team starts writing really bad queries, everyone's going to have a bad day, right? Furthermore, something else that's not a good idea here is, let's say the customer service team is accessing data in the database, and occasionally they want to get some ordering information. They're just going to join onto those tables, right? They're just going to access those tables. And you may say, well, that's not a big deal. Okay, it's not a big deal. But since the ordering team is now free to make their system as good as it possibly can be, they're going to start moving faster, right? They're going to move faster than they used to move. Now they're going to be implementing changes, schema changes, changing things, moving things. Well, what are you going to do? Put the customer service engineers on every single PR and it can't be merged until they agree with it because it might break queries that they're doing into your model? It's really none of their business how you persist the data storage. Okay, so let's say the teams understand that and they're like, yeah, this is not really helping us. Like we're not really decoupled yet. All right, let's get our own database persistence. By the way, one thing I haven't really mentioned yet is the data people. And by now they're probably getting kind of pissed off, right? Because now we've already fractionalized the databases, but every single team now has their own database. They're persisting it their own way. This is awesome for them. So the customer recommendations team is like, this is great. Now that we are isolated, like we've been wanting to move to Python to represent like some neural networks and this business intelligence system that we're building to represent and build these recommendations. We can make that move from Scala to Python. And the DB, it makes more sense for us to persist stuff as a NoSQL object. So we're going to go with Redis instead of Oracle DB or whatever it was. That's really cool. And they have the ability to do that now. But you can see here, I've drawn some arrows around like it looks like a spaghetti to me. These services are still tightly coupled to one another. They're just not tightly coupled by joining into each other's data anymore. Now what it looks like is happening when a request comes into customer recommendations, they may have to hit the inventory service to get a little more data to maybe round out a view model that they're returning. All right. So what's the problem with this? Well, let me ask you this. If the uptime of inventory service is 90%, that's a pretty lousy uptime, but let's say it's 90%. At most, customer recommendations is available 90% of the time, at most. And now they also have dependencies on some other systems, which who knows what their availability is. It's not really autonomy yet. What about their response time? So the customer recommendations team is full of incredible developers, and they just rocked this thing. And they got it down to like 100 millisecond responses. But they make a call over to that CRM thing, that customer service, and that thing is 500 milliseconds. And the inventory service and the ordering service are both 400 millisecond response times. And they can't be run in parallel. Well, now you have unacceptable response times, and you're totally not in control of it at all. That's not autonomy. Also, in these situations, this is where you get cascading errors, of course. So it's not that simple. I hope you all can agree. Like, you don't just do it because you may not really get yourself in a better state. What we really want is something like what you see on the right-hand side, right? What we really want is a request come in from iOS or web app or wherever it is, comes right to a service, and they fulfill that request in return. That's what we really want. That's autonomy. That's their ability to tweak what they're doing to be the best at what they're doing. All right. And I say that one way to meet that need is to utilize something called eventual consistency. Now you can see here the databases are separated and the services aren't talking directly to each other. They're not hitting each other, right? We're not going to have the inventory service accidentally go down because the customer recommendation service wrote a bad query in their N+1 API calls over to the inventory service, right? It's just not going to happen now. But you know who's unhappy here are the people who need access to the data in these other places. The people who are writing some big business intelligence system, they're like, oh my God, now what do I do? And I've been in these situations too. And the data teams and ETL teams are like, this is terrible. And I feel for them. It makes sense. So you're trading, innovation in one place for, it's going to be a little harder to do a couple other things, but let's talk through that. So eventual consistency. Remember I mentioned before inside your model needs to be basically immediately consistent, especially when those aggregates. Otherwise, there's a chance that you have an invalid model, and that is the worst thing you can have in the business. What's the point of having a model if it produces invalid data? So eventual consistency, by definition, is just these other systems. If your model has to be immediately consistent, then these other models can be eventually consistent, meaning like within a second or two or hours, right? It depends on the service level agreement, really. They can be eventually consistent with the changes that are occurring in these other systems. Let's take a look at that. So if we are going to be eventually consistent, that means data somehow has to move. How are we going to move that data? Well, the traditional way is like batch migrations. That's ever since I got out of school, and immediately I was doing batch migrations. I don't like these. I think that they have a purpose, but there's downsides to them. One downside, of course, with batch migrations is you have some kind of like query hitting databases on some cron schedule. But the ordering team, like I said, is going to be innovating. They're going to be changing stuff. It may break your migration. And then you have to understand their model of persistence in order to even be able to get the data out. Again, it's not really your business to understand how they persist the data. Oh, sorry, not a big fan of the batch migrations. That said, there's another way to do it, and there's the pub sub way to do it. Pub sub is publish, subscribe. Another way to say it is like producer, consumer. We're going to talk about events, and there's two major patterns, at least the two that I've used in the past, and those are the message broker pattern and the fully distributed pattern. We're going to look more at this than batch migrations. This is pretty sexy. I think it is. So real quick, I dropped a bunch of words, right? So let's quickly talk about what they are so we're on the same page. Pub sub, publish, subscribe. It's loosely coupling your system so that one broadcaster can say this happened and other systems can be aware of that change. It is loosely coupling from the standpoint of the producer. Okay, what is a message? A message is nothing more than a collection of data which is sent by a sender to a recipient, right? It's like if I wrote a note like this and I dropped it somewhere and Joaquin picked it up. That's all a message is. An event is a implementation of message. It's just a specific implementation of a message. It's an immutable collection of data that represents something noteworthy that has occurred only one time somewhere in the system. These are always in past tense, and we're going to be using these a lot going forward here. Then there's the message broker pattern I mentioned. This is a quote from Martin Fowler, I believe. Really, all the message broker pattern is a hub and spoke architecture, where you can say, this happened here, do something with it. And then the hub then says, who wants to know? And just sends it out to everyone. It's an extremely simple architectural pattern, and the software is actually extremely simple too. You can write it yourself, but there's great tools. We'll talk about those. And then event sourcing, event store, event streaming, they're different, but all related. This is all about just capturing and playing back all changes to an application state as a series of immutable events. It's really cool stuff. Okay, so I quickly typed up just a fake event in VS Code, and I realized that one of my attributes has a capital A in the front, but it doesn't really matter. So this is typically an example event that I would create. Event ID would be a unique identifier for it. A correlation ID is the ID that corresponds with the command that actually did the mutation. So in Verivend and ACV and other places, whatever, we always make sure that every command that mutates something has a unique identifier. So when events are generated as a result of this mutation, we can tie them all back to the initial thing that made the change. Event type is the fully qualified name of the event. So the service that produced it and the specific event, below it is the version of it. These things are always strongly typed, by the way. They have to be strongly typed because people are going to be digesting these people. People are not digesting them. Systems are going to be digesting these events, and they're going to be processing them and putting them into their own models. So strongly typed events is critical because they need to know the shape of the event. Timestamp, of course, is obvious. And then data is just that event that's being pushed into the data of the object that's being pushed into the event. Again, it's as simple as this. This is a broker, right? Publisher says, customer was onboarded. Is that what I have here? Customer added. Goes to the message broker. Message broker says, these three want to know about it, and gives it to him. That's it. So the message broker pattern, this is far less complex than the distributed one. First, I'm going to talk about just like the standard message broker pattern. It's something that, like, if anyone's ever used like RabbitMQ or something like that, that is essentially a message broker. You know where the broker is, you tell it of something that happened, and the broker knows who cares about it and just sends it out. It's extremely simple. It can be made highly available, very scalable. No one is running really complicated queries on it. It has one job. That's all it does. And it's really cool. It's really cool in that respect. One of the downsides, though, I'm not even going to say it's a downside. I'm going to say one way that you could actually make this even better is by utilizing an event store. So RabbitMQ, by definition, is queues. And queues, as we all know, are first in, first out. It means something leaves. The event store, nothing leaves. It's an immutable list of everything that has ever happened in an application state. So here I drew up this little diagram. We have like domain A, domain B, domain C. Domain A, something happened, customer added event, right? It goes ahead and adds a new item to its topic over here in the event store. That is there forever. Every time there's another event, it goes to the end of it. Every single service is doing this. Some services are reading from those events. And what they have, these little triangles represent like pointers that specify at what point in the log or the immutable list they are. So you could start that at 0 if you wanted to. If I'm domain C and I want to replay all events from A, I can just say like, put my pointer at 0 and blah, 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 blah. I'll read all the events up until the end. And I can recreate any data model that I want in any shape that I want to. This is super powerful in the case of maybe some new BI service starting up or some new neural networks that you're training and you want to bring in a bunch of data and repeat it over and over again. All you have to do is repoint all of your pointers to 0 on all the topics you're interested in. And then that data just comes flowing in. It's like an a la carte buffet of data. It's a beautiful thing. We've used Kafka in the past at ACV. We used Kafka and it worked out really well. I think there's other things that are great event stores. There's actually an open source solution called Event Store, which I was at an event in Denver and everyone was talking about it. It sounded great. I never have tried it, but it's out there if you want to take a look at it. Very cool, but this can allow you to take any system and bring it up to speed with data anytime you want. It's very neat. Okay, the last thing is if you want a fully distributed model, which is way more complex. Believe me, I've done these too, but they're fascinating. The cool thing about these is there's really no single point of failure, of course, but the complexity might outweigh that because Message brokers are extremely simple things. There's nothing very complicated about them, so it's almost worth it. So, okay, so in this case, I drew 3 different domains here. Each domain has a message service that is kind of side-carded to it. All right, in this message service, when one of these, let's say a service stands up in this domain, A domain, for example, or let's say B domain, a service stands up. It has a configuration along with it that says, hey, I care about events from these places. The message service sees that configuration and then lets these services know, hey, this B domain at this location is interested in your events. And then this message service says, okay, I'll make sure that we have outgoing queues for them. Now, if something happens in A, let's say a customer has been added, it says, okay, do I have any outgoing queues? I do. Put the messages in the outgoing queues. This message service is looking at these queues to see if there's anything to dispatch. If it sees them, it sends them to the correct locations. The message service puts them in the incoming queue, and then the B domain just reads off of those. It's really, really, really neat. It's also actually surprisingly more complex than it looks right here. I won't even go into it unless people have specific questions, but it is very, very, very cool. Doing like event sourcing with this is a lot harder because with a fully distributed model, that event store has to be in each domain, I believe, which I suppose is possible, but it just seems more complex. Okay, so my overall recommendation, I hope I'm good on time here. Yeah, I'm good on time. My overall recommendation is do isolate your models. It is worth it to isolate your models. Also isolate that persistence if you can. Identify the aggregate roots within your model if you can too, because that's where you draw your transactional boundaries. And that really is important. It really is. You don't want to get bad data inside your model. Implement an event store, because then it's like, what did I say? An a la carte buffet of data. It's fantastic. And all the data teams and all the other teams within your enterprise or your business will love being able to just pull data from that location. Again, all events do need to be strongly typed, though. You even with weakly typed languages like Python, whatever, you need to find a way to make sure that the events follow a specific schema. At ACV Auctions, we had an engineer who came up with a brilliant solution. He basically, I'm getting into the weeds a little bit, but he used something called a sidecar, which is like a Kubernetes pattern. And the sidecar would always validate that an event was valid before it got into the event store. That's a whole Pandora's box there to take apart. But if someone has questions, I'm happy to go into that. But yeah, even weakly typed languages have to have strongly typed events. It's critical. And I mentioned using event base. If you have a polyglot of languages, that's not always, you can't really do that, right? So if you have an event base in Java, you can't apply it in Python really. And the other thing that I want to talk about very briefly, it's the last like complicated thing that I'm going to bring up, is utilizing something called an outbox pattern. And it's so obvious, but I never really considered it until not that long ago. So we do use this at Verivend, and we used it at ACV as well. That's where we came up with it. But the idea here is, remember I mentioned like immediate consistency? Well, one of our fears that we had when we first started going into this avenue is, what happens if some command passes our model, right? We allow this mutation to happen, and then we go ahead and we persist it to our model. So it's persisted to our database. And then we go to tell the event store that it happened, and that fails. And we're like, well, that would be bad. We'd have to somehow be aware of that. We need really good monitoring to know like it failed. And that way the other systems could actually finally be eventually consistent. But someone brought up the idea, well, why don't we write it to the event store first? And then we'll write it to our model. We'll make sure it goes through all of the model invariants, and then we'll write it to the event store, and then we'll persist it to the database. But actually that's even worse, because what if you have database level constraints? What if like you have a unique key constraint or a primary key constraint that you didn't see in your model? That's a database thing, right? But now you've told the entire system that this happened, but it couldn't happen. It would have been bad data if you let it happen, because you can't have 2 users with the same email address, let's say. So that wasn't a good solution either. And then what we ended up coming up with is basically having all of our databases extend this outbox database, which gave every single one of our databases an outbox table. So anytime we mutated any data, we also wrote an event to the outbox. And in one transaction, we persisted that. So either both things succeeded or neither of them succeeded. The mutation of the data and the record of the mutation of the data had to succeed at the same time, otherwise they wouldn't succeed. And then we just built a dispatcher thread, which just looks for things in our outbox, kind of like what we talked about in that distributed model. and then dispatches them where they have to go. In our case, it was Kafka. In our new case, we wrote our own at Verivend. We have our own event store. But that is, I absolutely love it. I highly recommend going that route for consistency and for just making sure that all of your models are going to be having a good day. But this is kind of what we talked about, right? Most systems begin as like a kernel of a solution, and they grow into larger things, and that is okay. But it does make sense, and you will be able to move faster. You will be able to innovate better. You will get better performance if you isolate them and utilize all your skills on one problem at a time. We talked about jumping into a distributed system. We don't want tight coupling. We don't want it really at the database level. We definitely don't want it with services talking to each other. That's where you get cascading failures. And now we've distributed, we saw there's data problems. That database went to one big thing that the ETL teams loved pulling data out of into a distributed thing. And so you need to utilize new patterns and new architecture in order to be able to get the most out of your data. And that's where we start talking about event streaming and eventual consistency. And I gave my recommendations on that. Again, I hope everyone got some value out of this talk. I'm happy to take any questions.
Thanks, John. Yeah, this was like drinking from a fire hose.
Yeah,
it was a lot of information and a lifetime of experience and wisdom here. And thanks for sharing it with us. I think that is a good opportunity to also look at this from different points of view. You know, a lot of the details are important, but we would accept any questions of the big picture. So here I see one question for John. How best would you say a data scientist skill set would help yield eventual consistency, perhaps writing adaptive algorithms?
Yeah, absolutely. So data science, in my opinion, data science is more of a customer of this architecture than anything, right? You want to have access to all the data. Being a data scientist, see, I'm not one, so I'm not sure I can speak intelligently to the right way to apply data science to this. I think being familiar with this sort of architecture, I think is very helpful. I think more and more companies are going to this kind of mentality. Yeah, that's all I got there.
Thanks. Yeah. The issue is that a lot of our students, they are more consumers of all of these than the ones writing it up. But I think that getting a glimpse of different areas in this business is very, very useful. And actually, weeks ago we saw other presentations where the emphasis was on statistical analytics of the data, or also the issues like NP completeness. They will come out in the presentation, and people, I've never heard that before. And what I tell everybody is that nowadays you can just Google and learn any concept that you hear about, and
it's amazing.
So it is. So the important thing though is to get in touch and to hear from people that actually use the concept. We would contemplate any questions you guys have about anything related to entrepreneurship, what ACV options, Verivend, the roles, the different roles of people involved in a new startup, and also. How much of, for instance, of the issues that you discussed are things that you deal day to day in your company?
So with Verivend is my company now. See, I've been through this enough that I didn't want to go through it again with Verivend. So I actually architected everything initially in this structure because I didn't want to deal with the pain of breaking things out. It's a lot of work. And I've done it a few times. I didn't want to do it again. And I'm lucky in this case, I was here from day one. So I was able to build it in this fashion. So we do utilize the outbox pattern. We do utilize events. And we do have other systems that are eventually consistent. We have a recommendation system, which is constantly seeing what's happening in the system. How do people pay? Are they paying on time? Are they disputing payments? And then we're digesting that separately. See, a lot of people don't think about, like, a system can do many, many, many things, but they don't all have to happen in the user request thread. So think about, like, if you were to, let's say, buy something on Amazon.com, right? And you clicked buy, and you had to wait for all the things that happen in Amazon, you'd be sitting there for a while waiting. Why block the user input, right? Let these things happen asynchronously. And so I'm always thinking in that fashion. I abstract the system in such a way that pieces can run asynchronously if possible. And that's really all eventual consistency is. You're just allowing for asynchronous processing within their own models, within their own data structures, their own invariants.
Yeah, nice. Very, very, very interesting. The equation that you showed, 1 over alpha plus 1 minus alpha over p,
yes,
diminishes return. It's a very interesting model of what happens when you do things in parallel. And can you talk a little bit more about that aspect of going in parallel versus not, and how that relates?
Oh, sure. Absolutely. Yeah. So I guess all I'm saying is time is best spent optimizing your software such that more of it can run parallel, because again, the hardware is going to give you diminished returns. If you can represent the return in a polynomial, you'll be able to take the second derivative and see the inflection point to where you're no longer getting any return at all. So time is best spent figuring out how you can take your system and have multiple things happen all at once, or optimize those individual things that are happening. Today, most people are utilizing things like Kubernetes, ECS. So basically containerization and then orchestration of those containers. And so hardware scaling really is it's so cheap and so easy right now that it's very, I don't want to say lazy, but I will. It's like the lazy way to think about it is just Kubernetes will take care of it. Don't worry about writing really fast code, but you will see if your application really gains legs and you're getting more and more users and they're growing exponentially, your system may not be able to respond exponentially.
Yeah, we had a workshop last summer with AWS, and they covered many of their services. Kubernetes. They also had the different kind of containers and ways of. Now, do you use any cloud computing, or is mostly your own servers?
So Verivend is all in the cloud. So we're all in AWS, and we utilize ECS instead of Kubernetes, but it's the same idea. You wrap up your application into a container, and then you orchestrate that in some code definition. So we say, like, we want 4 of these things running, 5 of these things running. These things are allowed to communicate. Yeah, everything's in AWS. And ACV was the same way. It still is. It's all in AWS. I wonder sometimes if that trend is going to start changing and people are going to be going back to bare metal. I'm not sure, but I do know everything is a pendulum. And so I'm kind of waiting for the other shoe to drop and everyone to go back to bare metal. It'll probably happen. I mean, a lot of these, none of this is new. Even cloud computing is not new. It just is just vogue. That's all.
Yeah, absolutely. But the technology and the speed of transfer makes a difference. Actually, many years ago at Bob State, they wanted to have the software that we use in the classroom on the clouds rather than local. Mm-hmm. And I remember the first time I went to the classroom, it took 15 minutes for the thing to load up. The class is 50 minutes. I cannot wait 15 minutes for this. Yeah. And at that time, the transfer, right? The bandwidth was very, very, very low, and then it wasn't a good idea. So there are a number of factors that determine what's in fact fashionable. But would you give do you have any advice on what AWS certificates to get?
Which you mean in terms of
training for
certifications?
Students, certifications. So is there any that you would recommend for people that you hire?
I would say, so I don't put, this is not the answer you're looking for, but I don't put a lot of, I'm not a big fan of certifications. I'll just say that. So there's the Microsoft ones, the AWS ones, the Cisco ones, all that stuff. I'm just not a big fan. I guess as being a customer of graduates of these certifications, I don't always see the skills there, but I will say this. Kubernetes, everyone is using some form of containerization and orchestration right now. Kubernetes is definitely the popular one. If you were going to go for a certification, go for that. AWS is, I think it's by far the biggest cloud platform, right? Followed by Azure, which is gaining is gaining some ground. But if you can understand the basic workings of AWS and you understand how to manage like a Kubernetes cluster, you're worth a lot of money to companies. I mean, people are paying a premium for that kind of thing right now. And to be fair, data science too, I know how much people are paying for data science.
Let's see, I see another question here from Erica. It says, a lot of this was interesting to me as a machine learning engineer who needs to be familiar with our company's data pipelines and processes. And I agree with your opinion on Kubernetes. We also use this. I'm curious, does Verivend currently employ data scientists or utilize predictive analytics? Also, I know, Rodney, our kids go to school together. Very impressive what you all have done here.
That's great. Yeah, Rodney is one of my co-founders. There's three of us who co-founded the company. And yeah, I mean, we do want to employ data scientists. I want to do it responsibly though. So we probably are going to be hiring data scientists at our Series A, which is probably going to be in about 10 months. But I am putting feelers out there. So if anyone is interested and would like to talk to me, yes, there's a lot I would love to start doing. We have a lot of data and we're going to be getting more and more data. And I'd love to be able to start getting data from external sources and be able to start seeding our application with specific things. Now, real quick, with Verivend, we initially started as a platform for these like blue collar industries to streamline their invoicing and payments. That's initially how we started. One of our, someone just said, let's talk. One of our co-founders actually runs a bunch of blue collar companies. And he was showing me one day how he manages his receivables. And I was like, oh my God, this is before we started Verivend. I'm like, you do it like that? And his portfolio of companies is not small. We're talking tens of millions of dollars in revenue. And I was like, how do the other companies of your size work? And he's like, the same way. And I was like, oh my God, this is like, early days of ACV when it was like, there was like this mass opportunity because people were all kind of stuck in doing it the same way. Your enemy was the status quo, just like we always do it this way. And this is how we do it. And people don't have to accept that. I kept saying like, there are better ways. Maybe we can convince them of the better ways. So we started going down that avenue and we were seeing traction. There's no doubt about it. But we were so broad in our approach. Audio is going to know what I'm talking about. We're so broad in our approach. We were going after like all industries that needed to move money. And tips to anybody who's starting a company, that's not the right way to do it. Like you really do need to pick a niche and like be like, that's where I'm going to focus, because you just won't have enough resources to be able to support all of these different verticals and all of their different needs. Remember I talked about the model and those invariants? Well, try having a model that has to meet the need of N verticals. You're immediately going to get yourself in a bad place. And I kind of saw that happening. And I'm like, and we all kind of agreed actually at the same time, like we probably need to focus. And so where Verivend has focused now is actually on private capital. It sounds very different from blue collar industries, doesn't it? But it's still moving money. And we've signed up so many of these private capital funds, mergers and acquisitions type endeavors. And we've really found our niche there. And it's been a lot of fun working with these people. And so, yes, I do want to employ some data scientists and I want to get them working in the space and try to understand better this new industry vertical, not new to us, but our focus. That was a very long-winded answer, but yes, I'm looking for data scientists. Interns would be probably welcome.
If someone is interested in potentially working for your company or an internship, how should they contact you? Do you have an email address you prefer? LinkedIn?
I'll tell you what, I'll put it right in the chat and you can hit me up directly and we can talk. And if it's not right now, it'll be soon. Please definitely talk to me if you're interested in possibly an internship. But I also would be remiss if I didn't mention the really cool things that are going on at ACV with data science. Like I have to, because they are doing such neat stuff. I mean, we were building at one point a system that would build signatures of the sound of engines so we can detect anomalies. So if I have like a 1998 Chevy Cavalier and I rev that engine and we have enough of that data, which by now I don't work there anymore. I can't say us, but still a shareholder. I guess I can say us. But so if we can get enough of those signatures, then we can start to detect anomalies when we listen to that sound. And I was like, man, that is such a cool idea. And we built it, and it was called AMP, I believe it was called. And so cool data scientists working on that. The other thing we did is we found a way to streamline the title process. So as you guys probably know, if you own a car, there's a title associated to the car. But titles are specific to a state. So every title looks a little different. If it's a title from Montana, a title from Ohio, it's going to look different. And so a team of brilliant data scientists at ACV Auctions, led by a guy named
John Coles,
Steve
maybe?
Simpson. No, John Coles is great. Steve Simpson, though, was the gentleman. But they wrote just a fantastic OCR solution that could look at titles and immediately pull the relevant information out of them, up to like a 99.9% accuracy. I don't know if it's that high, but it was quite high. It was really cool. And there was even more things that we did. We managed to build something that we actually created hardware for it too, that you could drive a car over and it would actually take a bunch of pictures of the undercarriage and stitch them all together into one cohesive photograph. And we called it the virtual lift. So if anyone's familiar with cars at shops, like you lift up the car and you look under it. But at car auctions, they wouldn't be able to do that. And so we built this hardware. I can't take any credit for it. I had nothing to do with that project, but it was just so neat how it came out. I mean, industry leading, I would say. So they are doing cool stuff, and I'm not even aware of the stuff they're doing now. So I would say, if you're really interested, take a look at ACV Auctions. I don't believe Steve Simpson is there, or Steve Sherry is there anymore. Steve Simpson, I was right the first time. But John Coles is, and maybe I'll ask him if he minds if I give out his information, and I can share it with Joaquin, and we can go from there.
Yeah. Actually, John Coles used to teach for us.
Oh,
and he's in our advisory board. So he was in Kubrick, where Erica, who just wrote the question a minute ago, works now.
Oh, very cool. Great guy. Great guy.
Yeah, absolutely. And I actually found fascinating that creating databases is something that, you take a class and they tell you how to normalize things and you put the data here and there. And you hear stories like in Delaware North, one of our students was a high employee there. I don't remember his title. He's now a professor in Delaware. But he was telling me how they hired one person to put all the database at one point, maybe 10 years ago, 10, 15. I mean, things are moving so fast that there are places that 10 years ago, they all their data was in pieces of papers in drawers.
Yeah.
Then when you're talking about handling data in a very efficient way, there's a lot of intelligence that goes into it.
Yes, absolutely. There's a lot of white space out there too. So much still hasn't been done.
A lot of low-hanging fruits, and I see it in colleges, even that colleges resist to kind of innovate their system. That's because they don't have money. I mean, that's another issue too. Right. And but the government is even worse. I mean, it's like in many offices in governments. Actually, one of our students works in a nearby town, and he was telling us, how much help they need in updating their databases and their systems and the web page. And so there is an enormous need for a more efficient, just like you're showing, a manipulation of data, where it has to be in some cases distributed, in some cases, is local. Sometimes there are all these variables that go into place. So it's a very exciting time, but the language and the tools are totally new. It's like they were not around, I don't know, 5 years ago, 10 years ago. Every few years, there is a whole bunch of new things. I mean,
yeah.
Docker, Docker was the most popular thing a while ago, and now it's Kubernetes. I mean,
yeah, well, it's the logical progression of Docker. I mean, you could say, right? It's like, okay, we have these Docker images. What do we do with them? And Kubernetes is the solution to that. But it's amazing how quickly these tools become almost ubiquitous. Like from out of nowhere, all of a sudden, everyone's aware of them. And if you're not aware of them, you're not marketable anymore.
So how much? I mean, in your own case, how often do you have to reinvent yourself as a computer scientist? And
what a great question. I am constantly humbled, and I used to hate it, and now I love it. So I've been doing this for 20 years. I've been building systems, and then I got into designing systems, and then running teams and processes, and still architecting, and I let my head get big sometimes, like, oh, I'm great, but I'm not. Like I meet back at ACV auctions. I remember we hired a couple of guys that they were so much smarter than me. It was so cool to get to work with them. I was like, oh my God, I'm going to learn so much from these people. And then at Verivend, like we're a fairly small team. I don't know, 15 employees or something like that. I love it. We got people in there that teach me new stuff every single day, and computer science and probably data science too. It's such a fascinating place to be if you're open to change, because it's always changing, and it's not like civil engineering. I can say that my wife's was a civil engineer. She's a pharmacist now, but like that doesn't change that much. You know what I mean? But the world of like computer science and technology is like you blink and you miss it. And it's so exciting. It's a little exhausting too, but I would say that I'm constantly fighting with keeping all of my skills up to date, and you all will too. And as you get older, it just gets harder because you have more responsibility, but you do need to do it because you can very quickly become antiquated. The stuff that's going on now, I think, is really interesting. We're in a very interesting time. I'm absolutely obsessed with artificial intelligence. I've got books all around me on it. It's like my hobby, but I don't really get to apply that in my daily job. It's just like my hobby. I'm fascinated by it. I'm fascinated with the opportunity to like replicate a human brain. And my goal would be, when hopefully I have a nice exit here with Verivend, I kind of want to go back to school for that, because that's a whole branch of learning that I really never got into. Great question, Joaquin. There's so much to unpack there. Like every day I'm learning something new.
Yeah. I agree. The same here, and same with other people that I know. But another question is, do you recommend, say, just getting a good thick 500-page book and read it, or to read blogs from people that you're following?
Me personally, I will listen to podcasts and stuff like that for people that I admire. I normally read books, and I read books, and then I wish I had this stuff around me. I would show you guys, but I have these big drawing pads, and whenever something comes to me, and I draw it out there. So when I have an idea, and like I've been drawing out like this like model brain, I'm constantly drawing new pictures and new designs. But really, I get inspired by reading books, and I've got my favorite books, and some of them are really dry, and some of them are super interesting. But I'm definitely more of the latter. I take books more than blogs and things like that.
Have you tried the Lex Friedman podcast?
Yeah. Oh, absolutely. Yeah. He was, some of the people that he's talked to are absolutely amazing. And then he got into more like political stuff, and then like fighting and stuff like that. And that's all cool, but I'm less interested in that. So he kind of got all over the place. I think
he's gotten a little bit more all over but a lot of his earlier talks, they're all from people who are involved in AI in some degree. And I think his specialization at MIT is self-driving cars, if I remember correctly.
Yeah, he's at MIT, some form of data scientist, but I know he's very, again, interested. Lex Friedman is his name.
Yeah, Lex Friedman.
Yeah. He used to have the Artificial Intelligence podcast, and then he changed it to his name, I believe. But he really was, like you said, in the early days, he was very focused on that. And those are by far my favorite lectures. Like he's got so many good ones. Great one with Noam Chomsky that he forgot to turn the video camera on, but you still.
I saw that.
Yeah, that was a great one, right? I mean, there's so many good ones.
Yeah. Actually, one thing I'm going to do is to everything that I heard today in your presentation that I am not too familiar with, what I do usually, I go and check it out and I read about it. And somehow, I mean, if you're not the kind of read a 500-page book, but you hear a talk that is interesting, anything that I get from it, I go and I read about it, one little explanation of it, and that helps me also grow. Yeah. And this has created a culture of almost distributed or crowdsourcing expertise. So rather than being one person who knows the entire field, and he writes books, and then you only read those books, you hear from people that are learning, and you hear their opinion, and because that also has values in it. You see, you have your opinion is very valuable to me, and sometimes books try to be not opinionated.
Yeah.
So there are different approaches, different people have, but the one thing that I'm excited about is that the field of data science and entrepreneurship is a field of people that is very, very alive, curious, interesting, always learning new things.
Yeah, and I'll tell you what, hit me up anytime anyone wants to talk about entrepreneurship, starting a company, any of that stuff, because I'm very familiar with that. And I'd love to have a discussion. I'm sure I can learn stuff from you too. So yeah, I'm open to talks or discussion anytime, meet for coffee. If I can make it, I'll do it.
Can I ask one entrepreneurship question? I'm just at the beginning of the data science program, so I wouldn't be of much use in reference to computation. So punching a little bit above my weight with this talk. So I'll go, here's an interesting entrepreneurship question. How hard was it to get your first customer?
Well, so I would ask you a question in response. First real customer, right? So initially, one of our founders, I mentioned before, owned a suite of companies. And so the natural thing to do was to onboard his companies first and sort of see how it went as like a little laboratory. If we're going to make mistakes, we wanted to make it with his companies because they were going to be the most forgiving. That was easy, obviously, right? They were friendly. When we started to branch out, the hard thing that I find is building trust when you're fairly new. Like we're moving money for people. I mean, people were trusting us with all of their accounts receivable and accounts payable. That takes a lot of trust. And it was during the pandemic that we got this thing started. So I left ACV at the end of 2019 and we started this, and like shortly after that, everything shut down. And so it was a tough time to build trust because it was transactional like this, Zoom calls and stuff. I mean, I trust you guys fine. I'm just saying, like, it's not the same as sitting in a room with someone, shaking their hand and building that trust, right? So that was a little tricky. But I'll tell you what, like the first time we got our first real customer, it felt awesome. Like I wanted to like jump in there and click my heels, which I'm not sure I've ever done before, but like I wanted to do that. It felt that good. And then when all of a sudden you get other people talking about it and all of a sudden customers are telling customers, that is an awesome feeling too. But we have some bizarre stuff. Like we have customers that have nothing to do with what we're trying to accomplish out in like Los Angeles. So it's gotten to the point now where it's kind of spread out beyond what we thought it was going to be. But those first few customers, dude, that is fun. That is, and it is hard. And I wasn't there at ACV for the first couple customers. By the time I got there were plenty.
Great. Well, it's 7:00 and I know people have other things to do. Thanks so much, John. Thanks everybody for being here.